Thank you very much for having me today at the Manufacturing Data Summit Europe. My name is Eva Schönleitner. I am the CEO of CrateDB, a database solution specifically made for Industry 4.0 type of digital products. Today, we're going to be talking about what kind of technologies are really enabling Industry 4.0 solutions and smart manufacturing solutions beyond just early pilots, but what is really driving large-scale commercialization, both for internal use as well as for digital solutions at customers. We've seen that over the years, many of us and many manufacturers have been working on pilot use cases, utilizing machine learning, AI type applications, and really trying to move towards this Industry 4.0 concept in their various internal use as well as customer solutions. It's clearly here to stay. Just earlier this year, IDC brought out a new study around AI-driven revenues. Even today, this year, it's being forecasted that globally at $327 billion AI-driven revenues through various manufacturers in the market, with high growth rates over the next few years going up to even over $500 billion in just 3 years from now. So this is clearly here to stay. And how is this now happening? What we're seeing is that there is technologies come on the market that are specifically made or purpose-built to enable this digitalization. So the typical, I would say, technologies we've had before, we've all tested with and tried with, but as it emerged, now we're seeing high growth rates and also technologies advancing. What kind of technologies am I talking about here? Clearly, we all know the hyperscalers that have very high growth, and you can see the various projected growth rates here in terms of software forecast. But really what drives it also on top of hyperscalers and availability of cloud, just cloud solutions, connectivity on the ground, including 5G, machine learning databases, AI, machine learning tools and applications, complete AI or machine learning type software platforms or industrial software platforms, and also system integrators that specialize in helping our customers not only implement smart manufacturing solutions internally, but also build digital solutions that they can monetize with customers out there. So what kind of learnings have we had over the last several years of based on real life projects of what it takes to move into this smart manufacturing Industry 4.0 solutions set? One is that to start out with, going for my pilot is great and you want to do that, but in order to really think long term of how you're going to commercialize this or implement internally at larger scale, you need to make sure that you're starting with a highly scalable data infrastructure, because data is at the heart of everything here. And I'll talk about this a bit more. The second one is make sure that you have a clear data governance model. Where is the, call it the master? Where does the master of each data sit? Where do you just consolidate? Where do you report? And where is the master of each data? And where does the data go and who has access? And that's very important, not just for internal use, but now, of course, with cloud use or hybrid solutions then as well. The last one is, I mentioned pilots a few times, and that's still valid. To just think, oh, we did a few pilots and now off we go and we're going to do this grand implementation of some new use case without testing it first is, I don't believe, the right way. To go from rapid pilots and testing into a small deployment, into then a scaled up deployment is still the way to go, especially in the area of manufacturing. When we're talking, and many of our customers are in the area of really affecting the control loop of so the manufacturing process itself. And there, of course, high availability, super high security is critical. So in terms of applying new software technologies, you want to make sure this is super stable, super safe and super stable before you move it into production. Hence the idea of rapid pilot, small deployment, large deployment is the way to go still. What you will see and what we've seen with our customers is that the timing it takes to go from the first pilot to deployment to the next one accelerates, because we all have learnings and what works and what doesn't work. The teams get practiced and whether it's distributed teams or a central team. As you go through multiple of those, you really speed up, but still the process stands. And the last one, and that's what I really want to talk today, is initially, as we know, manufacturing started mostly from an on-prem land and situation. Then we all moved into the cloud, especially with applications like ERP, reporting, and many other ones, but really not quite the manufacturing floor applications. Initially, as we were piloting and trying out Industry 4.0 solutions, it's perfectly fine to actually go 100% cloud on this, because you just deploy much faster, you can try much faster, and you can also centrally manage that. However, as we have deployed actually live systems with and starting to scale with our customers, we realized the amount of data created at the edge, meaning at the factory floor in this case, or at the source of where this data, the machine data, gets produced, is exponentially high. If you send all this to the cloud, there is limiting factors to this, not on scalability. You can scale the cloud unlimitless, but it's a factor of one, cost. Two, do you really want to send all this data, especially machine data, meaning like sensor data, to the cloud? Some areas you have restrictions in terms of government regulations or sensitivity of data. And the fourth one, if you're in remote locations, you might not always have 100% uninterrupted, very fast cloud access. If you then address time-sensitive, operations in your manufacturing line, this becomes a problem or an unnecessary risk. So what we've seen over the years now is clearly the edge and having some compute at the edge is critical. And what is the difference between edge and what I talked to on-prem? There is quite a difference. So when we look about how do I build something like this, what does something like this look? And let me walk you through this. So we have the machines in the floor. Machines could also be in ships, in, I've just picked the manufacturing site, in trucks, wherever there is a sensor data or machine kind of data being produced. Then we have the traditional systems, the IT backend systems, the ERPs, the CRMs, and so on, been around for a long time. And the business processes being attached to these ERP and traditional systems. Customers, it may be internal, but also external customers want to access the information from all of those. Think vendors, think downstream customers, think forecasting and inventory optimization. The same goes then of machine status. And that is not your own production, but customers want to know when are things coming, what's the supply chain cycle, and want access to this. So you collect this data. And how do you collect the data? The data on the right is fairly easily collectible. We've been doing this for years on the ERP systems and so on. There is classic APIs, interfaces, but the challenge comes really on the left, on the machine data side. We all know this is where the crux is. We have machines that are older than 5 years in service, not all connect in the same ways. Newer standards are out there, but anything older, there is a diverse ecosystem of machines or devices out there that need connectivity. So this device and connectivity management, also one of these new applications that is come around, and new technologies, is critical here. What you do then, and what we all want to do to enable smart manufacturing or Industry 4.0 solutions, is to analyze all this data, not just to analyze the right ones, the backend system, but to analyze this data that's coming out of the machines. And the new solutions and what we've been doing with customers is to then basically build a cloud-based system, and I'm talking about cloud-based here, that brings all this data from the IT systems and the OT systems together into one database. Not multiple. You may have multiple, but it's actually one solution, talking about my own, there's other ones. And then from there, you can actually act. You can act in either going back to the machines, you can act having applications on that, or you can also for own use, or you can monetize this. You can monetize it with your customers in digital solutions that run off your basically infrastructure. You can monetize it through services. Think not only you want service people, but you can also monetize these services to your customers, and also your R&D department will want to have this information as well. So this is actually what we've been building and what a lot of companies are gearing up. This totally scales. It works great. It gives you the ability to centralize the data into both structured data coming from their backend IT systems and unstructured data. Unstructured being sensor data, images maybe, or text that comes from the machine side into one, analyze it there, and in real time, not historic, in real time, then act on it. What does what we see as a next generation of this is what I just mentioned. If you really want to scale this, due to the very high exponential increase of the machine data on the left side there, we recommend that we do an edge, combined edge and cloud compute. So when we hone into this, the green part there, where this data gets collected, what we're seeing is the next generation is that the machine data actually gets collected at this edge, meaning on-prem component. You actually do the analysis in the applications on the edge, meaning in, let's say, a factory or in a ship or in a windmill, anywhere where it is close to where the data gets collected. You do the analysis and the acting right there. You also have user applications on top of that to make it easy to actually do something. And then you then do the same thing. Some of the data goes up to the cloud-based systems, which they are now on the right. You can still do the same monetization, but you do the bulk or a large part of the analysis of the machine data on the edge where you act as well. So why am I saying this? What we have here, what I just described, is not going back to the on-prem systems, but it's the next generation. Basically combining what the benefits of what we have in the cloud, this unlimited scalability, the visibility globally, to actually managing some machine data and the control loop on the edge, meaning on-prem, on-site, where the data gets created. However, this is not disconnected here. You want to manage both the technology, in this case, CrateDB is our database, but the technology both in the cloud and on the edge, and you want to have it managed centrally. That's the big difference in terms of management. If you do it on-prem, you would manage it, think somebody has like 200 plants, a customer. If you have an on-prem application going on, you need to manage it 200 times and then somehow figure out how to sync this if you want global visibility, the old model. The new model is the combination is you manage it, you deploy it from the cloud centrally. But however, the data analysis happens then on the edge at the location. And then some of the locations, it doesn't need to be continuous internet connectivity. You can also then occasionally sync data, and you don't have to sync all data, but you can just sync select data. This means, let's say you take sensor data of temperatures, and the temperature is always the same temperature, 20 degrees. However, you want to send all the 20 degrees you measure every half second up to the cloud. Maybe not. Maybe not. Maybe you want to send the outliers. Maybe you want to send the trend. This way, you compress the data. You really only send what's relevant. However, if you then, let's say, have 200 plants, you manage this. As a plant manager, you only see and really worry about one plant. Me as the head of operations or head of quality, I worry about all plants. So I want to see all of them. And this, the cloud structure and the syncing in the cloud of the various components, basically the locations, what I call, you see there's different types of locations, to sync that into one enables you to then have the global visibility, also real time. So let me give you an example of what I'm talking about. One of our customers, Alplause, you may know him, I'm sure that you know them. They're a world market leader in plastic packaging. Think Coca-Cola, or think many plastic items like soaps and dishwashing liquids, many of these hard plastic items, containers we see in our grocery aisles. They have 180 plants in 45 countries globally. And what we've done with them is exactly a solution what I just described. And I'll have a picture, a little picture on the left. I've blown it up on the next page. But basically what they try to do is improve the operations through a affecting real time the operations of the production of these plastic bottles. And how do they do that? Let me just show you. Down there on the left, you see the different, well, this is, let's see, one plant. One plant had multiple lines. There is information, meaning all the plant machines are connected with each other. And then it goes up to the cloud, and all the sensor and machine data go up to the cloud into, in this case, the Crate database. And from there, we built a notification system and lots of rules around it. So kind of a workflow that basically tells you what steps need to be happening for the worker in each different roles. You can see the roles at the bottom, which roles we have for each worker throughout the day or throughout the shift. It basically tells you, please watch out for the next step and check off these items. It also tells you if there is alarms going up from each machine. And you may say, well, this is obvious. There's always alarms in the machine. Yes, there is, but each machine is different. Each machine has their own system. And so what we did is an overlay of that to basically pull the information from all machines. And any machine basically goes in, the alarms trigger through this, I would say, notification solution. It goes then via the cloud immediately to people's Bluetooth earsets, which are also noise canceling earsets, into their mobile devices where the application sits. And then basically it tells them, watch out, machine 4, line 3, there is something running out of alignment, or there is an issue of some sort. There's a lot of reason codes in there. And you basically, then the worker, in this case, the operator can go over there and basically fix this immediately. And this is all real time. Today, this is all cloud and it's live in almost 20 plants globally of the 180 plants. Now, as we're thinking of globalizing this, the edge solution comes in because today everything is over the cloud, but then locations are remote. The cloud is not continuous and not stable enough in some remote countries. So you clearly want to have this on the edge. What are some of the NEs or the benefits of this? And please see on the right, huge cost savings. One hand of combining the data into one central area versus having multiple databases and places of analysis sitting. And the second one is real operational savings. In this case, we took the one plant. We looked at all the plants, but we took the best performing plant and looked at what is the operational savings on top of this. And it's quite significant. So if you want to know more about this, please contact me directly and I can tell you more about it. So what did I talk about here? I talked about cloud and edge solutions. Crate is a database specifically made to house these machine data and the structured data coming out of ERP systems, analyze and be able to transact real time across a massively scalable solution. We have an early adopter program for the edge solution, which we recently launched. Please, if you're interested, please join that and contact us. And also today at the conference, please look further, visit us at the booth for more information. And also you can get for us a virtual coffee and chat. So please come to the booth for more information. I really appreciate that of how one can really make something like this happen. And if you're interested in learning more or really interested in specifically some of the architecture I just described, both cloud and edge, at this database, the CrateDB described that can basically house very cost efficiently, highly scalable real-time data to help analyze, and specifically also this one solution I just briefly described that we have implemented at Alplause that is made by ourselves, and I'd be very interested and happy to discuss it with you some more. And as a final, I'd like to thank you very much, and please come find me or find someone in our company after your coffee chat and after learning more. Please use this QR code, or you can find me on LinkedIn as well. Have a good rest of the conference.